Let's review what we know about transformations. When we have a shape, there are 4 different transformations we've learned about to move or alter the shape. One is that we could reflect the shape or flip it over a line, making a mirror image. Another is that we could translate or slide the shape. Another, we could rotate or turn the shape. And the last, that we could dilate the shape, making it larger or smaller. If we need to identify which transformations happened to a shape, we need to first think about whether or not the shapes are similar or congruent. In this case, the 2 triangles are not congruent, which means that it's not simply reflected, translated, or rotated. It might possibly be dilated, though. Dilation changes the size. We need to look at coordinates for the points and see whether or not each coordinate was multiplied by the same number, called a scale factor. If we look at the point C, we can see that it starts at the point 2, 0 and ends at the point -3, 0. So what number would change a 2 into a -3 by multiplying? We can divide to find that scale factor. -3 divided by 2 is -3/2. Let's check the other 2 corners and see if they were multiplied by that same scale factor of -3/2. Point B moved from -2, -2 to +3, 3. We can divide to check the scale factor, and 3 divided by -2 is the same thing as -3/2, so the scale factor is the same. We've got one more point to check, and that's point A. It starts at 3, -5, but the ending point has decimals, so we're going to try multiplying by -3/2 to see if it's plausible. 3 times -3/2 is -4.5, which looks like it's about where that point is. -5 times -3/2 is +7.5. That also looks like a valid option for where that point ended up. It looks like everything was multiplied by -3/2, so this is a dilation with a scale factor of -3/2. Let's see another example. We want to check to see how this figure was transformed. First, we're going to look at whether or not it's congruent or similar. These figures are similar. They're also congruent. They are the same shape, but they're also the same size. Since they are still same size, they have not been dilated, so that gets rid of one option. Now we need to see if it's been flipped, rotated, or slid. Well, if this shape was just slid, it wouldn't have been upside down when it ended in the red shape, so it's not a translation. It's either been rotated or it's been flipped. Let's look at point A. If we rotate point A, it would end up at 4, -5, which is instead where point B is. Point A ended up at 2, -5, so this hasn't been rotated. It's been flipped. Since we flip it down over the x-axis, that would put all of the letters in the right order, where A flips down on the left and C flips down on the left, B flips down on the right, and D flips down on the right. However, it still needs to be slid over to the correct place. That's the next thing that happened, is a translation 6 units to the right. Once your point lines up in the new final image, you know that you've run out of transformations that need to happen. This figure was reflected over the x-axis and then translated right 6 units.